بسم الله الحمد لله والصلاة والسلام على رسول الله. الطلبة الأعزاء، السلام عليكم ورحمة الله وبركاته، وأهلا ومرحبا بكم في هذا الجزء الثالث من المحور الثاني لمادة الرسم الهندسي 2 والذي بعنوان Dimensioning Objects Features. The basics concept. Dimensioning is accomplished by adding size and location information necessary to manufacture the object. This information have to be clear, complete, facilitate the manufacturing method and the measurement method. One example, this is the designed part. We need two views. To manufacture this part, we need to know first the width, the depth, and thickness of the part. These are dimensions, should be clear. Okay? S denotes size dimension, L denotes location dimension. Second, the diameter and the depth of the hole. Okay, this is diameter of the hole. We need to know location of the holes. This is the location of the hole. Okay. Right. Angle. To dimension an angle, use circular dimension line having the center at the vertex of the angle. One example here. This is the angle. Okay. We use this circular dimension line. Okay. This is another example. This circular dimension line have a center here. The center of the vertex of the angle. Okay. Here, this is the angular dimension. Common mistakes here. For this vertex, this center, circular dimension line have no center here. This is wrong. Arcs are dimensioned by giving the radius and the views in which their true shape appear. The letter R is always lettered before the figures to emphasize that this dimension is radius of an arc. Here, for example, this is the dimension line R200. That's mean the radius of this arc is 200 millimeters. Or to put directly, this is from the center, or to put directly here, extension from the center, are 200 millimeters. The dimension figure and the arrowhead should be inside the arc, where there is sufficient place. Sufficient space for both. There is the first example here, R200 from the center. Sufficient space for arrowhead only. Move figure outside. Okay, R62.5 for example. Here too, R58.5 millimeters. Insufficient space for both. Move both figure and arrow outside. Like this example, the space is not enough for both. We have to put R6.5 millimeters outside. Leader line must be radial and inclined with an angle between 30 to 60 degrees to the horizontal. This is 30 degrees and here 60 degrees. So the leader line must be inclined radial between these two angles. For example, here it's okay, R62.5. Common mistakes. The leader line is outside, 30 and 60 millimeters. This one should be extended outside. That one is outside 60 and 30 degrees. Sorry. Here we have an example too. This is inclined but outside 60 millimeters. This is also wrong. Use the foreshortened radial dimension line when arc's center locates outside the sheet or interfere with other views. This is the drawing sheet. This is the view. When the center is outside the drawing sheet, we have first method is to extend the line from the center, and that's all. Second method is to move the center here and put zigzag line. Fillet and rounds. Give the radius of a typical fillet only by using a local node. We have an example here. R 6.5 millimeters. If all fillets and rounds are uniform in size, dimension may be omitted, but it is necessary to add the note. All fillet and round are, give a dimension R, for example, 5 millimeters. Here, all fillet and rounds are R is 6.5 millimeters. For that one, for example, all fillet and rounds are 6.5 millimeters unless otherwise specified. This one is it is specified different to the given are 6.5 millimeters. Curve. The curve constructed from two or more arcs requires the dimensions of radii and center's location. This is an example. We have to specify the center, radii, and center location. Common mistakes here. This is the tangent point. This is wrong. It should be here. Okay, that one should be here. Okay. Cylinder. Size dimensions are diameter and length for the cylinder. This is the measurement method. Location dimension must be located from its center line. Here we have a shape with a cylinder. On these views, we have to locate the center of the cylinder. The diameter should be given in a longitudinal view with the symbol phi placed before the figures. This is a cylindrical shape. This is two views. Okay, we have to put the diameter as per this notation. For holes, size dimensions are diameter and depth. Measurement method is the following. Location dimension must be located from its center line. This is a shape with two holes. On these views, we have to locate the center of the holes. Holes with small size. Use leader line and local node to specify diameter and holes depth. For example, through thickness hole. Here is not with phi xx, for example, phi 10 millimeters, or phi given diameter and we put through, or another method, xx drill, for example, 15 millimeters drill. Other method, xx drill to specify the diameter and put here through. Use leader line and local node to specify diameter and holes depth in the circular view. Blind hole. Here, we specify the diameter and the depth with local nodes. Or other method, XX drill to specify the diameter and to say that is drilled and not re-init, and here to specify the depth of the hole. Holes with large size. Use extension and dimension line. This is to put diameter, phi xx. Use diametral line for dimension. This is also, it's okay. Use leader line and note outside the hole. Common mistakes for holes are, for example, to put from the arrow of the dimension line is not inside the hole, the circle of hole. This is wrong. Also, to put to specify hole with R, this is wrong. The inclination of this line is not between 60 and 30 degrees. This is wrong. Here, the arrow is directly on the center. This is wrong. For the big hole size, to put diametrical line, dimension, and external note, this is wrong. Also, this one is wrong. The diametrical line on the center line, this is wrong. And here also to locate the hole, this is wrong. You have to locate the center. Okay? And from here you have to locate the center. For chamfers, use leader line and note to indicate linear distance and angle of the chamfer. For example, here we can specify this chamfer with this dimension and with this inclination, this angle. Or dimension multiplied by angle. For a 45 chamfer, the most used, we can put C, that's mean 45 chamfer, and S, this is the dimension of this chamfer. Or directly here to put S by S, this is mean 45 degree chamfer. Round end shapes. Dimension it according to the manufacturing method used. Here, for example, with these local nodes, okay, and dimension, these holes should be drilled. First hole here, and second hole. We have to specify center to center distance. Dimension it according to the manufacturing method used also. We have this example, local nodes and dimension. To make this hole, we use this milling process. Okay, and we need then center to center distance. Dimension it according also to manufacturing method used. This is another example. Local nodes, okay. And center to center distance is specified. Here too. Here we have to specify the tool distance. Okay. This is the tool cutting distance. Should be specified. Here it's okay. Dimension it according to the standard sizes of another part to be assembled or manufacturing method used. For this key, we need to manufacture this keyway. Key, it is a standard part. Okay, so we have to specify the total length of the keyway. Another example here to show the manufacturing process of the keyway. We have to specify center to center distance.